Good morning, Alexis. How you doing?
Hey, Stefano, how you doing?
Yeah, I'm doing good. Okay, today is a really buona la prima. This we just pick up the thing and say, okay, let's do this recording. And I know you have an argument to put on the table, but yeah, on my side, it's gonna be like, okay, let's see what's going on.
Well, yeah, you were literally like, "Hey, want to chat?" And I was like, "Want to record?" And so,
That's
why
it.
don't we just chat about what we're working on, and hopefully, it's interesting to others, maybe. So
Also,
one thing I could
that's
talk
episode
about.
17, by the way. We make a long run.
Oh yeah, we're like an institution now. I mean, it's us versus like the Byzantine Empire. Okay, so here's a thought. Two things that's connected. So once upon a time, hundreds of years ago, I wrote this blog post about why Claude Code won. You remember it, right?
I remember.
In that
Yeah,
blog post,
we discussed in this very podcast.
right?
That thing was awesome.
And at the end of that blog post, I said, Claude Code won because um, it gave the agents a expressive composable tool um, called
Right.
Bash that they can use for doing things with files. But the big opportunity here is that there are all sorts of data that are really important to us that are not expressed as distinct files on the file system. The most obvious one being email. Like your inbox is a list of messages. It's not a directory of files anymore. Once upon a time it was. And there's a huge opportunity to create a tool which uses the insights that allowed, the insight about what makes Claude Code powerful in order to make access to your email powerful. In order to do that, what you need to do is you need to create a tool that allows the AI to have a composable, rich language for interacting with your email. And then you get all the power of an AI, and that you can talk to it with natural language, and it can understand complicated queries. Um, but that AI itself will have the power of a composable, flexible, expressive query language to actually look at the email. If only someone would do that. That was my point at the end of why Claude Code won. I don't know if you remember this. It's a bit of a recap.
I absolutely remember this one, and I even remember your really interesting idea that why UI are not composable because you cannot pipe two different windows and say, oh, can I pipe the content in one and the other? You can't. Instead, with Bash, that was the one of the really interesting and key insight you made it there is that with Bash you can compose the basic building blocks and the pipe command that actually stream data one comment to the next to the next to the next is the thing that lets the system lets you this the Unix philosophy behind the scene
Yeah,
make it simple one purpose command but able to be composed with the other, and then you pipe it, you put a script, you create multiple instances of that.
exactly. Yeah.
So
And Unix
exactly, that was
philosophy has
really
actually been
great.
articulated. If I recall in one of the
Yeah.
footnotes to that article, I actually found publications from the 1970s or 80s where people who worked on Unix were saying these are the principles of Unix, which they kind of realized after the fact. Like everything is text, everything is composable, text is in streams. Another interesting way to think about this is that Bash, which is the kind of language for manipulating processes in Unix, is in some ways the language that has the most sophisticated concurrency system of any programming language because it has like automatic, composable, concurrent like processes and coroutines with a really good syntax. People don't think of it that way, but that's like what it is. The job control system, the pipe control system, the background system. You try to do the equivalent thing in Python, and it's a goddamn mess. Like you can do it, or in Java, or in like, C or whatever your grown-up programming language is worse than Bash for the uh, day-to-day business of I need to put together a lot of things into nice little pipes so that it's all kind of pull-based and streaming.
Yeah.
Bash just does it better. Okay, so, all right. So I said, someone will do this for email, and it'll be fantastic. And okay, so no surprise, I did it for email, and it's fantastic. So let me tell you the story. So
Yeah. Let's describe what actually you did, because I really think it's a kind of the direction that what I'm doing in another domain, but it's really interesting to see we're doing the kind of same
have
approaches.
we been recording already for 17 minutes? Please tell me that's not
No,
true.
no, no. This is like the time we were discussing before. Say
Okay. All
hello.
right. Thank you.
Don't worry. It's like
All
five
right.
minutes we will be recording. Don't worry.
All right. All right. So I'll give myself 10 minutes. Okay. So I'll tell you what I did, then I'll tell you the punchline because it's a nice little story. So I thought I want to design the language, which is the ideal language for querying email and understanding email, right?
Love it.
And I want this language to be the language that the AI prefers to use for email. Because the whole point of this is to create a tool that AI can use for email, not to create a tool that I can use for email. AI
Exactly.
first. This is like AI, like accessibility for AI, um, usability for AI. Like I use natural language, AI needs to use this language for email. So I had different ideas.
It's the new UX, and think that in the same episode that we discussed about your blog post, we even discussed about the DSLs, the power of DSLs. So you want to do like a domain-specific language that is
Exactly.
suited for AI to be
Right.
optimized. I got a lot of like side
So I
topics.
had a lot of ideas. So first, my first idea was, well, if I'm making a nice, clean language, like obviously it should be a Lisp, right? Because everybody with any taste knows it should be a Lisp. So I, with the help of AI, designed a Lisp dialect, which is completely optimized for the purposes of like querying email, having composable, like semantic queries on email, an email that's from a person that was connected to a person about this topic, right? So that was one category. And then I thought, well, I shouldn't just be a smug Lisp weenie bigot. I should explore other possibilities. So I also designed a Prolog based language, thinking like email. It's kind of it's the other spectrum, like kind of a logic language.
Raising the bar here.
Yeah, you can like logically express the condition that represents the email you want to find. It's from so and so. It's not from so and so. It's within this, and the
Yeah.
language translator the Prolog interpreter will just go and like find you the language.
And,
Um,
and at the end of the day, you collapse into a bash command, or you're still
and yeah, and then I also had things that were more like the native, Gmail query things. Like, okay, here's a thing to find something by this user. Here's a thing to find something with this keyword. And I thought, well, part of what you're doing when you want to do rich queries in a language is you want to have primitives that are semantically rich. So I designed a query language that had semantic primitives. So instead of just saying who's the user, you could have a semantic primitive that says this is like a positively emotionally valenced message. This is a negatively emotionally valenced message. So you could do a query to give me all the negatively emotional messages or all the queries that are
Mm,
about the topic of employment, all the queries that are about the topic of password reset. So kind of higher level semantic predicates. There's like a set of semantic predicates
yeah.
involved,
Okay.
right? So then the idea is you can use like a weaker model to pre-index all your messages using
Okay.
semantic predicates, and then the stronger model can just have this higher level language that it can use.
So
So I had all these,
you're like embedding stuff, not like simply regex and
right,
finding
right. So you're
stuff.
not just searching over the text of messages
Okay.
or textual facts. You're searching over semantic facts. So I had all these, brilliant, dare I say it, interesting ideas, and the goal of like, and then I implemented a query tool using every one of these ideas. So I didn't just I implemented the list-based, email query tool, the Prolog-based one, the one with semantic predicates, also the one that was more like SQL, right? Um,
Okay.
and I'm sorry to report.
No, no, no. It's great. It's like the new way of making it. Think about like a
This
year
is an
ago.
ablation. It's basically I'm doing a language ablation where I'm trying like different
Awesome.
languages and then I had, rich
You should
queries
write a
based on
paper about
my
that, by the way. You already did the
yeah, yeah.
inflation. Uh,
Baby, I ship products. I don't ship PDFs. Boom, right. Um, so that's not true. Any big lab people listening, I also ship PDFs. So if you want to work with a
yeah.
PDF with me, I'm game for that too.
You
Um,
could do that.
but yeah, so this was essentially an ablation to take a kind of rich set of queries and a rich set of email data, and then try lots of different query languages, and then see which query language the AI liked best. And that was measured by things like um, does the AI produce syntactically correct queries, the most like trivial thing, but
Mhm.
also how many different tool steps does it take for the AI to actually complete the query and find the email that it's supposed to find,
This
right?
is
So
a
is it
really interesting point.
Hmm.
Like evaluating the number of turn the AI need to call a tool and putting things out is a really, really interesting point. Really interesting metric.
Yeah, so that's one of the metric that's one of the kind of metrics of merit for an agentic tool. The other ablation, and this is the one I have not seen anyone do, but it's very important,
Yep.
is what is the weakest AI that can use the tool? Because if you have a crappy tool, a badly documented piece of software that someone made who does not understand the user, does not really care about being clear, just thinks in their own way and just like puts it into anything that they publish, well, if you have a smart enough AI or a smart enough person, they can figure out how to use a badly made tool, right?
Yeah.
But what makes a tool really good is that you can use it when you're drunk. You can use it when you're stupid. You can use it when it's like 2 p.m., 2
I
a.m.
love
at night.
I
You
love
can use it.
the drunk proof tool. It's the
Yeah,
thing.
yeah. You can use it when you're like, as I was last night with Sparky, like at a demo event and you have a
Oh, I
weak Wi-Fi
remember I saw
connection
that video of
and,
yours.
and you need to get the thing running in 10 minutes because a bunch of people are going to come downstairs. Like you don't, at that point, you don't want to like, you want something that's so easy to use. You can use it even when you're impaired, in a rush, and compromised. And so
It's,
what
I
people should
remember
be
when
doing,
last video you recorded, you switch the model to Sparky and you say it's like when you're drunk because you're running like Nemo's from local thing. So
yeah.
yeah,
So when you're building a tool that's intended for agents, an important ablation is see what is the weakest model that can still use the tool successfully. So I had those two criteria in mind. How few tool calls does it take for an agent to get to the result, and how weak a model can use the tool successfully? And use the tool doesn't just mean use the tool; it means read the instructions for the
yeah.
tool and then understand how to use it. Okay, so a lot of setup because the answer is very disappointing. I had all these fun ideas for the right way to do this. But the answer, as is often the case in engineering world, is not fun. It's really boring. The right answer is SQL. The right answer is SQL.
Course.
Why? Obvious reasons. The same reasons that I put um, in the Claude Code article. Because the agents already know about SQL. I don't know if SQL is the most perfect language for querying, but it's the most familiar language for querying. It's
Exactly.
already in the training data.
It's
Um,
the AI comfort zone. And like
right.
the human prefer things they know.
Right. So at the end of the day, I did all of this work, and the answer was just use SQLite, use exactly the SQLite syntax, and just add a kind of
Love it.
schema around SQLite. All of the semantic predicate stuff kind of just got in the way. Um, all of
Uh,
the
can you
exotic
install
languages.
the embedding there is one embedding, yeah, more than one open source embedding library to deal for like semantic search inside a SQLite.
It,
You can
you
add
know,
it if you really need the semantic stuff. You can add
I
like
don't know. Here's what I know. I did a bunch of tests, and the embedding and semantic stuff did not improve results. So maybe if we get Ben Clavier or the guys at Mixed Bread who and ladies at Mixed Bread who understand like the right way to do like re-ranking and semantic search to like jump on a podcast with us,
oh, oh,
we can get a more sophisticated tool. And my God, let's do it because that's a gold mine to have a good way of getting an email. But my like modest efforts, which involved a lot of experiments, just found that agentic search produced a better result. So just give the agent a search tool and give the agent the ability to keywords. Basically, if you look at the way they do the search, they you say what you want, and then it generates keywords, and it kind of keyword spams the search tool you've given it, and then it figures it out. And so what I have right now is I have a tool called Email SQL. It's a command line tool written in Go, of course. Um, and uh, whenever I have anything I need to do with my email where it's a bit of a hassle to find it, I just talk to my agent, maybe just talk to Sparky, and they just uses that tool and pulls out the result and gives me the Gmail URL or opens it up in a browser. And it works fantastically well. And one measure of how well it works is the complexity of the queries that I can put to it. Because the queries are the queries you could give to an intelligent human being. They're not like the queries that you think of doing when you're operating the Gmail interface. So I can say things like, "Hey, what was the like last message I had with Stefano that wasn't about a podcast, but maybe involved a mention of an Australian that we know," and it'll like find it. if
Yeah,
there's a message that
I
meets
I
that
got two
criteria.
arguments to put here. Like you quote about like Ben, and this is a fun story. He's the author or re-ranker, right?
Ben Clavier.
Yeah.
Yeah, he's done a lot of stuff in re-ranking. I don't remember the
So,
exact
uh,
project, but
kind of a year ago, in my like experimentation, I made a modal public notebook. We should link this in this topic on this video. And I actually tried all the combinations, re-ranker everything, and I try to understand what was the best way to re-rank. And at the end of the day, the very, very, very best way to re-rank was like a small GPT model. Just you get like 150 results, and an LLM re-ranking them was by far beating any like late interaction, anything else. It was beating so good that I DM and talk with Ben itself. Say, Ben, this is something wrong here. Like, it's impossible. That's so good, 100% good. And say no in like your domain and your things. Yeah, very good argument about like because the number was so good that I was thinking I made a mistake. I said it wasn't. So I
yeah,
just showed.
no, I mean, I think there's a way, and there's
So you don't need it
situations.
at the end of the day. Long story short, you don't need a re-ranker. Just like rather the small model say, please re-rank those.
I think there's a lot of situations where a lot of all the clever stuff we learned when we were studying classic machine learning is just completely wiped out by putting a strong LLM at it. That's not all situations, but there's a lot of situations like that.
There's
Um,
there's a lot. That's gonna be material for another like
yeah.
episode. This
So
one.
so so I guess like to summarize, I'd say the moral of the story for me is um, if you want to have a really powerful search, create a search tool that's optimized for an AI, do basic ablations on it to make the tool optimized for a weak AI and make the tool so good that the AI doesn't need to do a lot of tool calls. And you can also explore the design space around the language that the AI is given, but you will probably end up finding out that the most familiar, conventional, boring language is the right one. And so I've done this for email. It's great. I've also done it for my calendar. It's great. Everyone should do it. I could ask Sparky an email question right now if you want to see it in action, but I don't know if that's that interesting. I hope he doesn't pull
I
up anything
absolutely want to see
embarrassing.
this in action, and I think that we'll make two episodes about your email and your stack because there's a bunch of other things we need to discuss about. So, but live demo. Let's. Hey, Sparky, by the way.
All right, so what should I ask about? That's a good question. Um, okay. Uh, Uh, hey Sparky, could you check my email and see if there are any password reset emails that I've received in the last, I don't know, 2 weeks, um, and tell me how many they are and where they're from.
Okay, let me check.
Oh, your voice is gone. Your audio is gone.
I found 3 security-related emails in the last 2 weeks. One from Snapchat about a new login attempt, one from DoorDash with a verification code, and one from Walmart with a verification code. I didn't find a clean literal password reset email, so these are the closest matches.
There you go. What I
Okay.
was
Yeah.
trying to say to you, I was trying to mute him, but then I realized this button doesn't mute him, it mutes you. What I was trying to say is I don't know if he's doing this thinking in the background or in his voice loop. So he does thinking in the background, but right now it's a little discretionary if he decides to handle a task in the background or in
Oh,
the same loop that does thinking. So there's uh, a lot of subtleties in that design space that need to get optimized. Yeah.
uh, okay. Yeah, we're a bit like close to 20 minutes now.
All
So,
right. Well, we should wrap.
Alexis, that was really interesting. And I want to put on the table a thing that we should leave for the next episode, maybe starting from exactly this idea that
Technically, that one ran in the same voice tone. I gave a quick let me check. used email SQL, then answered when the query came back for longer searches. I should push it into background work and report back when it's ready, instead of holding the voice loop open.
It's okay, Sparky. We got the answer at the end of the day. I'm going to wrap up the podcast now, so you can keep your thoughts to yourself for a moment.
There we go. Yeah, I want to say that the idea that you put on the table that we should design interfaces and not really API interfaces for language model that are optimized for the use of something from an agent is a different kind of design challenge than all the things. There's one point that you mentioned before. You say a lot of reason why you should pick a language instead of another or an approach instead of another. And you have even another one, even the amount of thing that your function return should be compatible with your context size. There's no sense the system returns you a 2000 email in your context. They should stay in some like state in the answer, and the language model should grab thing when they need it. Is a kind of like far away the idea of the RLM. So you have
Yeah, no, I mean that's just,
an
I mean,
AI that
I
can
agree.
manipulate this huge amount of things instead of
I
grabbing
agree.
all of those
I
and putting
agree.
it in the
Yeah,
context. So
so
that's
there's a number of design principles here. Progressive disclosure, as a kind of context management to minimize context rot. This is already how skill.md files work with a small description and then the body material so the LLM can
yeah,
search
yeah.
through that. So I think there might be value if you have like a ton of email and maybe pre-summarizing like some of them so there's a smaller search space. I don't know. I
This I don't
haven't like
know.
what.
This I don't know. But I was when you were saying this, I was thinking when we have a long scroll list, what we usually do for human in the website, we have the infinite scrolling. We have something that do not load everything and do not ask everything from the server, just asking a batch of things and moving on. And you scroll. But
I
if you
agree, but
search, if you search,
mhm.
you're gonna ask to someone that has all the rows and give you back the thing. So it is like this new way of interacting that's aimed to be simple to be used for AI. That is very important. And I've got really one last bit on my side that we should absolutely unwrap the next time. That is the AI can manipulate everything. If you give your AI like a DB SQLite database and say, okay, these are my email, find the thing. AI will on the fly invent a new function and create itself a small program to do that. But it's very inefficient. If instead you, maybe together with AI, you design a good way really thinking to the optimization of the process and say, okay, now you have this new abstraction, this new DSL. Use this, create a skill that shows example how to use it. This is going to be the very best way. And I think that what it is really, really interesting and even really, really useful. I want to try that thing. So
Yeah, no, that's what I've done essentially. Because if you just gave it all the raw Gmail as I put it onto my computer offline, it wasn't optimized for search. So what I'm designing is the right structure for search, and then the AI is only given that, but that thing is expressive and flexible enough. So it's a language design problem. It's a search optimization problem. It's a cognition optimization problem because you're optimizing a tool for a certain cognition profile. Just like you might, write a set of instructions to install a piece of IKEA furniture so they could be followed by someone who doesn't speak English or followed by a child. In the same way, there's a lot of like to go into some of the details. We should really wrap up here, but if you look at the email SQL tool, there's like a dash dash guide, which gives the guide for an AI on how to use this tool. And one of the ways in which it's optimized for a weak AI is that it does not offer too many abstractions. It doesn't say, here's the general, primitives, compose them. It says, here's an example of this kind of query. Here's an example of this kind of query. That stuff's at the top. And then further down, you have instructions that are intended for a stronger AI or for more difficult challenges where it's like, here's the schema if you want to like go nuts with it, right?
yeah.
So you have this thing that, weaker AIs have weaker power of abstraction, but they're able to do pattern matching better, or they're very able to do pattern matching.
They
So
can.
if you create like template searches that are kind of the right pattern, they'll get pretty far. You want to write things in such a way that a person or an agent or whatever doesn't need to connect too many dots on its own to understand the implications.
Yeah.
So I think that we are all still very unsophisticated at looking at a thing and appreciating how much cognitive depth it actually requires to process it. I think, like in my conversation about local models, we have this tendency to think certain topics are like big brain topics and other topics are small brain topics. And that's not the right way to look at it. The right way to look at it is something about how many steps, how many jumps you're required to make looking at a thing in order to comprehend it. And it could be a really small brain topic, like how do I get the printer working, right? Oh, the printer says this is the designated like port name, and the printer says that the port name needs to match the like paper tray. And so there's like two reasoning steps that you need to connect to get your stupid printer working. And no
Yeah.
one is gonna like say, "Oh, you're such a smart chap. Of course, like you get printers working. Let me pay you big money." But actually, that reasoning process is the hard part, right? Whereas someone that can just like regurgitate, "Oh, Heidegger has a fancy name for this," like that's not actually a reasoning process. That's just a recall process.
Yeah,
And even though
remembering.
someone might, really respect you at a cocktail party if you do that. It's not actually a proof of a kind of like cognitive capability.
Intelligence.
Um,
Yeah. You know.
yeah, so I don't know, and I think we're all very
Alexis, this
we're
is
all very
really
naive about this. We're
it's an
now way
interesting
past time,
topic.
bro.
And I know, interesting topic and a really interesting like application. And I would really say let's pause for now and jump in back in the next episode. Okay?
All right, man.
Cool. We want to see this live next time, like a really moving stuff and things, a generated query. Let's dirty our hands next time. Okay?
Yeah, maybe I should open source it. I for some reason I haven't, but
That's what I'm trying to push you on. Like I'm trusting
Well,
you.
how about if like
Yeah.
five people
I want
five
to
people
use it,
actually
by the
watch
way.
this?
So
If 10 people watch this and ask me to, I'll do it. All right.
okay, okay. I will find like 10 people doing that. Thanks,
Okay.
Alexis. Bye. Bye, Sparky.
Bye-bye.
Bye.